A young perspective on hot-button issues around the world. This is The Hub.
With the World Artificial Intelligence Conference taking place in Shanghai this week, entrepreneurs, scientists, and innovators from around the world are gathering to showcase the latest advances in artificial intelligence and explore the future of AI governance, offering a window into China's rapidly evolving innovation ecosystem.
As countries race to shape the next wave of technological transformation, innovation is becoming an increasingly critical driver of economic growth and global competitiveness. The World Economic Forum and Frontiers jointly presented the top 10 emerging technologies of 2026, highlighting innovations expected to have a tangible impact on our lives over the next 5 years. The report's release also comes as China continues to expand its role in the global innovation landscape, leveraging its manufacturing capacity, research capabilities, and large-scale deployment of new technologies. Joining us today are Stefan Mergenthaler, Managing Director and Chief Technology Officer of the World Economic Forum, and Dr. Frederick Fenter, Chief Executive Editor of Frontiers. Here is our conversation. Stefan, welcome back to Dalian, China. We've seen some exciting new technologies potentially changing and transforming our lives. What do you think are the notable trends in discovering and exploring these 10 technological breakthroughs?
We featured many world-changing technologies in the past, and this year, again, we have a very interesting and promising list. That's the result of a very thorough process with a scientific advisory board that we have. And we see an interesting trend this year towards really more personalized technologies, more localized technologies, and technologies that help us reduce the resource intensity of our economic processes.
All right, that really leads to my next question, that is scaling at scale, which is the theme of this year's conference. What are the potential obstacles preventing all these exciting new ideas to go from laboratories into the lives and you and me and everyone at site?
Yeah, it's a really, really good question. And that's also at the heart of this report, our Top 10 Emerging Technologies report. In fact, when we started, we had it purely as a scientific exercise where we polled scientists, what is coming, what do they see coming out of the labs at a given time. And over time, we actually said we need to add perspective on this in terms of what is the strategic outlook, what helps us scale or not these technologies. And I think there's a very simple and clear through line. It's two factors. It's about financing. Often these new breakthroughs are in domains that don't necessarily attract early commercial finance. So having the right finance to bring these technologies to greater scale. And then regulation, because of course bringing sensitive technologies that affect medicine, food, heavily regulated domains. These are domains where countries have developed consumer protections, regulations to ensure that drugs are safe. It's for good reasons that we have these regulations, but they're different in every country. And so for the innovators we talk to that are at the origin of these scientific breakthroughs, that's one of the big barriers. Bringing them to market in different countries requires a regulatory understanding in many different countries. And that's why this kind of dialogue that we can host here at the World Economic Forum, where we bring together the scientists, the innovators, governments and businesses together to build that common understanding. What are these promising new technological breakthroughs, and how can we bring them to market in a more effective way? That's really one of the objectives of this meeting.
What then do you think are the hopeful enablers for these technologies to be expedited in terms of coming to our lives and transforming our lives for the better?
You know, one of the hopeful enablers is actually one of the technologies we featured a couple of years ago in our report, which was AI for scientific discovery. What we see now is that many of these new breakthroughs are the result of AI for scientific discovery. It accelerates, it pushes the boundaries of what is even scientifically discoverable when you can build models of cells and don't have to rely on the actual lab experiments themselves. You can build thousands of simulations in near real time. That really accelerates the scientific process. And we see that reflected across the board in the technologies themselves, and also actually in our own process in finding and sourcing these scientific discoveries. This year, our report for the first time actually switched from starting with surveying scientists to actually starting with the AI-assisted workflow and then getting the scientific judgment after we had a first result from an AI-driven process.
Very good. So talking about the specifics of these potential technological breakthroughs, how many of them are, or which particular pieces of them do you expect to be industrialized or commercialized in the early stage here in China, given the ecosystem that is available here?
Yeah, one of the things we look at, of course, as part of this report is our patents in those different technology domain, and we see there across the board, China is one of the leading sources of patents in domains across those 10 areas that we identified. It's also, of course, the scale of the industrial basis here in China makes it very conducive to scaling the rollout and commercialization of some of this. But of course, these are very fast developing areas, and having a dialogue across disciplines, across the science, the policy, and industry remains an important priority also here, right? And that's why we are really pleased to have this annual meeting of the new champions here in China and have these important discussions here.
You know, when you first have this annual meetings in Dalian and Tianjin alternately, China was known largely as a world factory, and then becoming this manufacturing powerhouse. And then the narratives in the West somehow shifted into China becoming this innovation hub, even a leader, a trailblazer in areas like electric vehicles. How do you look at the innovation ecosystem here in China from your vantage point?
Yeah, one thing that we can see, of course, very clearly over the years is a very strong focus on policy consistency across several 5-year plans. Now we've seen a very strong focus on these new productive forces, looking at the technologies that are driving change and bringing them to industrial scale. And so that is, of course, we see that reflected in the electrification of the economy, the progress on the clean energy front. And that's why we also see so much interest from around the world here in understanding the Chinese innovation landscape. I think that's one of the focus areas of this meeting as well. And we see, given the record number of participants from business leaders globally also, that's I think one reflection of trying to understand, having a dialogue and understanding what works in terms of that strong innovation focus that China displays.
Given the fragmentation that we're facing realistically today when it comes to global policies and geopolitics, how worried are you that we're finding ourselves into having to accept two standards, two systems, and even two value-based systems that are actually hindering innovation for the next phases?
Yeah, I think it's fair to say that fragmentation is a key concern that is top of mind for business leaders, for policy leaders. And it's also fair to say that to really scale the transformative potential of these technologies, and our theme here is innovating at scale, So to truly scale, I think we need three areas of collaboration. One is in terms of the scientific collaboration. I think a lot of what we are talking about here is enabled by an open science collaboration where there is a lot of exchange and understanding in the scientific community that enables some of that those breakthrough. The other is in terms of the scaling and diffusion strategies, right? Understanding how do we scale and diffuse these technologies in industries needs common understanding, exchange. That's a strong focus of our work with different industries where we bring together leaders in helping understand that. And the third, let me just end on that, is the regulatory cooperation, right? That's what I mentioned. It's one of the biggest inhibitors to scaling these technologies. And we do also, I understand that's not always easy in a context where there is more and more political fragmentation, but we do need to have discussions about regulatory cooperation as well.
But some of the real-time events seem to be moving towards the opposite direction. If you look at scientists being questioned and investigated and racially profiled in some major powers towards Chinese people of Chinese descent or Asian descent. And we think about Chinese electric vehicles or solar panels, EVs, having difficulties entering some major Western European markets. I mean, this is block confrontation, hijacking economic and innovation potentials.
Yeah, like I said, I think the fragmentation is one of the things that is top of mind for many of the leaders that are coming together here. And that's why forums like ours, where we can bring stakeholders together from around the world, across sectors, to understand these different perspectives. There are different perspectives, and we need to make sure that there is dialogue to foster that understanding. We cannot just ignore it. And so the dialogue is tremendously important. And then within that, hopefully finding areas where we can move forward together.
We're living in the age of artificial intelligence. What kind of collaborations do you hope to see between your organization and the China's AI sectors?
Well, in terms of the scaling of artificial intelligence, we've all seen amazing breakthroughs in the last years. The frontier models that are coming out of the frontier labs have amazing capability. But we also understand that now the real frontier is translating these capabilities into real progress within organizations, adopting these technologies in different sectors. And that's a challenge that neither the tech sector alone nor any one company alone can really master. And that's one of the focus areas for our work in our Center for AI Excellence, where we bring together the most transformative use cases for deploying AI with real impact within organizations. Many of those actually come from China. We have many transformative use cases that we highlight in that program coming from Chinese companies, and fostering a dialogue about and an understanding about what are the success factors, what is needed to translate these capabilities into real economic impact. That's the focus of much of our work.
In Chinese, there's an ancient proverb that says, a change in degree will eventually, at some point, lead to a change in kind, 量变到质变. So where do you think we are in terms of accumulating the power and momentum of artificial intelligence towards finally and fundamentally touching and transforming our lives on a scale of 0 to 10, perhaps?
Well, I think we're only starting to see the real impact. I think we've seen the amazing capabilities, but we haven't seen that deep transformation of the way organizations work, the way we create value, the way we deliver medicine and healthcare, because that requires our institutions to adapt to that. And that will take a little bit longer. So I would say we're in the first third of that journey, maybe, with a lot more progress to be unlocked. And that is less focus on technology and more about translating those technologies into the organizations.
Focus on what's relevant in China and the world. Bridge the gap between what you know and what you want to know. This is The Hub.
Dr. Fenter, great having you with us on CGTN.
Thank you very much. It's a great pleasure to be here. Thank you for having me.
With your presentation just now of 10 emerging technologies of 2026, we're anticipating, we're more hopeful than we before we walked into the room, because these are indeed the technologies that could potentially transform our lives. In your opinion, what are some of the more exciting ones?
There's the radiative cooling, which is basically the idea of putting a coating on buildings. And this coating has certain properties, which is, first of all, it's extremely reflective, so most of the sunlight gets reflected, and it has compounds in it release heat in certain frequency ranges of infrared that escape the atmospheric window, so it actually does not get trapped in the atmosphere. So what you wind up having is a surface that actually cools lower than the ambient temperature, and it's just so to speak a thermodynamic trick. So it's that I found a very intriguing technology.
So it would save a lot of energy and lots of hassle during summer times for those societies and locations where they worry about the costs of rising energy costs.
Absolutely, and so that's one I think that has quite a bit of promise. As I said, as a chemist, that was the one that I found the most intriguing. I think the technology that probably has the most potential in terms of making a real impact in society is the world model approach to artificial intelligence. I think that in the past, in these reports that we've published, there's always been in the recent years a very heavy emphasis on artificial intelligence, generative AI, large language models, and various applications of artificial intelligence. This year, the report has the specificity of relying very heavily on physical systems. So 8 of the 10 technologies are actually quite heavily grounded in physical systems. I think the very big exception is the world model, which is about building types of artificial intelligence modules that are trained with real world data. So like a child playing with a ball, the child starts to intuitively understand how gravity works and how a ball bounces just from the interaction. Doesn't try to create a formula for gravity and calculate. Just is able to observe and become and understand intuitively. Artificial intelligence will also start being able to integrate this real world data and start making these types of inferences. And I think that we'll see that over the next few years, these types of models will become extremely useful in, for example, robotics, and in terms of humanoid robotics. They'll give them an entirely different level of ability to interact with their environment compared to today.
Yeah, because we've seen robotics performing martial arts not so long ago at the Lunar New Year Gala, presented by no other than my organization, CMG, where they're performing martial arts, and on YouTube they got 100 million views. How impressed were you at that?
It's extremely impressive. I think is that with these world models, it will become even more impressive. I mean, when we see, for example, the robots who run the marathon, a lot of times the movements are a little bit jerky. You can see there's some kind of like programming that's going on behind. Robots will learn how to walk smoothly. They'll be able to walk.
Great. I also noted 2 very promising technologies. Exosome drug delivery, personalized mRNA cancer vaccines, and also quantum simulation for drug discovery. All these are related to how we live our lives and treat our diseases.
Right, exactly. And every year in this report, the technologies are very often grouped into two or three categories. We have the energy category, some the environment category, which are very much linked to each other, the human health category, and the information category. So the world models probably falls into the information category, but the human health category, that's this year. That's the cluster of the three technologies. I think what's interesting there, mRNA technology for cancer vaccines. This is something where there is a very deliberate movement towards personalization of medical care, of precision medical care. This is a technology where vaccines are developed for an individual patient, which depends very specifically on a biopsy that has been performed. It looks at creating antigens that will prepare that patient's immune system to fight a cancer. The drug, in terms of quantum for drug discovery, that's also about being very, very precise, about being able to do simulations on molecules so that pharmaceutical companies can eliminate some of the weaker candidates very early in the pipeline. And what that will do is it'll allow drug development to be done in a economically sustainable way for a whole new catalog of diseases for which today it's very difficult to find the right financial circumstances to take that type of research forward.
How far are we from having this quantum simulation for drug delivery, discovery produced, mass produced and available for the large part of the world?
And we're confident that this is something that has a reasonable timeline of 5 years or so. This, I think, is also the theme of this year's Dalian Summer Davos is about scaling innovation. And so that's why I think the report this year actually fits quite nicely into that overall theme. And that, I think, is the beauty of this report. It's about finding the technologies that have the potential of scaling to an extent to be able to bring benefits very, very broadly to everybody in society.
China is increasingly perceived as an innovation powerhouse, an innovation hub. How do you like China's innovation ecosystem from your vantage point?
Yeah, well, look, I think that it's very, very clear that China is an innovation powerhouse. And I've been working in scientific publishing for 30 years, and I have watched with absolute amazement the rise of China from the mid-1990s when there was very, very little international scientific publication happening in China, to today, when China is the #1 producer of scientific knowledge in the world, of patents, of publications, of impactful science. It has been an incredible development over the course of just one generation. Very, very impressive. Why is China so successful? I think it's because there is the fact that policy is aligned with correct infrastructure, and I also think that there is the right mindset in China. I think one thing I tell people is that my hero is the engineer, my hero. They take an idea from the laboratory and they make it something that brings benefits to everybody in society. China has a very strong advantage on the engineering side, and I think that that's something that will continue to reap its benefits, to help ensure that China maintains its advantage in innovation.
Behind the mass production of engineers, do you think underlie a key factor that is the STEM education in China? Because according to some statistics, China produces more STEM students each year than India, than the United States, far more than the United States and the rest of the world.
Yeah, I mean, I think absolutely, and hopefully a large number of these STEM students will wind up in studying science and engineering. I think it's absolutely the right investment in the future of a program, of a plan to maintain that lead in the innovation space.
And then finally, how would you describe what you see when it comes to China's entrepreneurship?
I think I won't pretend to be an expert in international entrepreneurship, but I can say that, in our interactions with the World Economic Forum, in our participation with with our Science House project and annual meeting in Davos, the entrepreneurs that I talked to from China have always deeply impressed me by their focus, by their drive. I've seen examples of prototypes of similar technologies being developed, for example, in Europe and in China. In 10 years, the prototype becomes a full-scale industrial solution in China, and that same prototype is still very much a prototype in the European laboratories. And there's something there, I think, which speaks to the support that the entrepreneurs are getting from the government.
Dr. Fenter, thank you so much for your insights.
Okay, thank you.
And that will do it for this edition of The Hub. Thank you so much for tuning in. I'm Meng Guan. See you again next time.